Hello, in this lecture we are going to mention XGBoost framework and we are going to build a Hello World application with XGBoost. First of all, XGBoost is available on PyPy and you can install it with calling this command pip install XGBoost if you haven't installed it yet. But I have already installed it, that's why I'm going to import XGBoost directly. We are going to build decision trees for this dataset. It stores gold playing decisions based on some features such as outlook, temperature, humidity and wind. Here outlook and wind features are nominal, whereas temperature and humidity features are continuous. Import the dataset first, that's why I'm going to import pandas. And my data frame will be pandas.read csv, and here I'm going to pass the golf2.txt, name of the dataset. Let's see the content of my data frame. XGBoost framework expects us to transform nominal features and the target into the numeric ones. Here I'm going to apply label encoding for the target decision column. In other words, I will convert no decisions to 0 and yes decisions to 1. That's called label encoding. On the other hand, I'm going to apply one-hot encoding to outlook and wind features. In other words, I'm going to drop outlook feature and add new features is sunny, is overcast and is rain. And all of those columns store 1 or 0 values based on the base outlook feature. Let's set the target label here at decision and get the target label values here. I need unique values for the target column. These are no and yes. By the way, I'm going to apply label encoding for target here. Store those unique target classes into a variable unique decisions such as, and here I'm going to build a for loop for I in range from 0 to length of unique decisions. And let's print the unique decisions first. Also print the index value here. I'm going to replace 0 instead of no and 1 instead of yes. I can do it just like that. Get data frames, target labels, and if it's equal to current decision, that's the current decision, and get its index values and store those indexes in the id x variable. And I wonder the index values. Let's print them first. I need to replace the target columns to 0 for those index lines in the data frame. It's easy with pandas. I'm going to call data frame dot log function and I'm going to pass the indexes as a first argument and the column name as second argument, and these are going to be changed with the index value. Let's see the data frame here again. As seen, no classes are replaced to 0 and yes classes are replaced to 1. Now I'm going to apply one-hot encoding for features. I need to get the feature names first. I can get it just like that. Drop the target label. Target label was decision, and get its columns. Let's see the feature names. Now build a for loop for feature names. For feature in feature names, and data frame, get this feature and get its data type. Let's see the content of each feature. For example, outlook is object, nominal one. Temperature and humidity are numerical features, and wind is a nominal feature as well. I need to apply one-hot encoding for object types. That's why here I'm going to check the data type of the column, object, and print this line if this condition is satisfied. I need to apply one-hot encoding for outlook and wind features. I can change this line with just like that, applying one-hot encoding for this feature. Now I need to get the unique classes for that feature. And store it in the unique classes variable. And let's see the content first. For example, outlook has sunny, overcast and rain classes, and wind has weak and strong classes. Applying one-hot encoding is easy in pandas. Let's print a separator here first, and here let's call pandas.getDummies function and pass the unique classes as first argument. And let's see its another arguments. It has a prefix, and I'm going to pass the current feature name here as prefix. And let's print this first. As seen, getDummies function expand the outlook feature into its unique classes. Let's store this in the one-hot variable, and also set feature column of the one-hot variable, one-hot data frame into unique classes. And let's print this one-hot data frame here. See, when outlook is sunny, then outlook sunny feature is 1 and the other features will be 0. Similarly, if outlook is overcast, then outlook overcast feature is 1 and the other features will be 0. That's the typical principle of one-hot encoding. I deactivate this printing line. I'm going to merge the raw data frame with this one-hot data frame, and its common column will be feature. And let's apply left join here. Let's print this. For example, in the first item of the data frame, the outlook is sunny, and its outlook sunny feature will be 1 and outlook rain feature will be 0. One-hot encoding is applied, but I need to store this in the original data frame, and I no longer need to this outlook feature because it's expanded one-hot encoded way. Data frame is equal to data frame dot drop, and drop those columns feature. Let's see the content of the data frame here. See, we don't have outlook feature anymore. Instead of this, we have outlook overcast, outlook rain and outlook sunny features. and these are one-hot encoded columns. Now my data frame is ready. I can build decision trees with XGBoost. Let's apply the modeling step. This is a classification problem, and the target column just has yes and no classes. That's why this is a binary classification. That's why I'm going to define the objective function binary logistic, and evaluation metric will be log loss. This is for binary classification. If your problem is regression, actually we can define this problem as regression as well. In this case, the both objective and evaluation metric values could be root mean squared error. But I would like to define this problem as binary classification. Additionally, if your problem is multi-class classification problem, then your objective function should be multi-softmax. I actually can handle this. Is regression parameter can be defined here. Let's set it to false. If is regression is true, then set these values to objective and evaluation metric values. Otherwise, this would be classification. The both binary and multi-class classification problems, evaluation metric will be log loss. But here I need to check the number of classes in the target column, target label, and get its unique values and get its length. If it's equal to 2, then this would be binary classification. And let's set this is a binary classification problem. If this is greater than 2, set objective function softmax and print this is a multi-class classification problem. Here I can print this is a regression problem. The else condition is satisfied in my case, but the both binary and multi-class classification lines printed. That's because of I forgot here equal expression. This is a binary classification problem. Now I need to define the learning parameters, and that would be a JSON file. The first parameter will be learning rate, and it's going to be, for example, 0.0.1. Number of boosted trees will be stored in the number of estimators. That's going to be, for example, 250. And finally, object will be objective. Now it's time to build trees. I need to check is regression variable first, because if this condition is satisfied, then I'm going to call XGBoost regressor and pass these parameters. Otherwise, I'm going to call XGBoost classifier and similarly pass those parameters here. Those are going to be our model. Now I need to define the evaluation set. to apply early stopping to avoid overfitting, and that's going to be Python list, and its first argument will be features. I can get features just like that. Drop data frames, target label column, and get this our first argument. Those are features, and get just target label here. That's going to be the target column, and that's going to be also the second argument of evaluation set. Normally I should separate the evaluation set and train set, but in this case the number of instances are too low. Let's check. There are 14 instances, that's why I'm going to pass the same set to the evaluation set. Now it's time to training. I'm going to call model.fit, and here I'm going to pass the features first and target values second. Also evaluation metric will be evaluation metric parameter, and evaluation set will be evaluation set as well. Let's check other parameters in the fit function. Early stopping runs, I'm going to set this value to the 5, for example, and also set verbose parameter to true. Now it's time to training. I'm going to call fit command, and it returns an exception. I actually realized the problem here. I forgot here the parenthesis, the first one, and actually this parenthesis should be and here. Because I need to pass those values as tuple. Let's try to call fit command again, and it started and it's ended. As seen in the first line, it says that it will train until validation loss hasn't improved in 5 rounds. If it's not improved, then the training is terminated. Training is over, and let's see the model explaining. I'm going to call from XGBoost import plot importance library, and call plot importance and pass the build model here. Humidity is going to be the most dominant feature in my dataset based on my boosted trees, and sunny outlook sunny comes after the humidity, and wind strong comes after the outlook sunny feature. Some sources mention this explanation under model interpretability. Now let's make some predictions based on build model. I'm going to call the build model dot predict, and here I'm going to pass the features I'd like to predict, and let's pass the raw data set. And those are going to be my predictions. Let's see the content of predictions, and let's see the original values. It seems that just the last one is not classified correctly. The other ones are classified correctly. Remember that this was a classification problem, and those are the classes, dominant classes of my predictions. I can actually find the prediction probabilities. To find it, I'm going to call predict proba function, and again I'm going to pass those features. Prediction probas. Store these prediction probabilities in the prediction probas variable. And let's see the content. For example, the first item is classified as no because the probability of no is greater than the probability of yes. The third item is classified as yes. And let's see the probabilities of both no and yes. Probability of yes is greater than the probability of no. That's why this one is classified as yes. But I need to call those block if its regression is false. Because if I call predict proba function for a regression model, then it will return an exception. So we mentioned building boosted trees with XGBoost framework and developed a Hello World application with it. Thank you all for watching and see you next time.